Hello,
Hi.
welcome.
How are you?
Thanks for being here, and thank you to everybody out there in the audience. This is a super fascinating topic that I've actually been reporting on in recent years. And before I have you introduce yourselves, maybe just a brief explainer what bioacoustics are. Surprisingly, this newer field in science, maybe the last decade or so, scientists have really been better understanding what the noises from an ecosystem can actually tell you about the health of that ecosystem, which sounds obvious, right? Like you want to listen to the animals, what sounds they're making. But it's just really this nascent field. It's super fascinating, and I'm super interested in your project. So if you could introduce yourselves and tell us about this project of yours.
Yeah, I'll go first. My name is Radhika Krishnan. I am the Chief Product Officer at Hitachi Vantara. And our focus is really building data-oriented software and services that help a variety of customers in various verticals and industries. Over to you, Bourhan.
Yeah, hi. My name is Bourhan Yassin. I'm the CEO of a nonprofit organization called Rainforest Connection. Rainforest isn't our name, but we focus on protecting all ecosystems. We do that through the power of sound, through acoustics, either detecting illegal activities such as deforestation or poaching, or conserving species and animals. So understanding the forest landscape and the soundscape through sound. We do that in order to protect forests and ecosystems in general.
And if you could explain how this technology actually works, and maybe explain how Hitachi fits in that. I don't think most people think of rainforests when they think of Hitachi. How have you partnered on this technology, and how does it work?
Yeah, so the way the technology works, so acoustics or bioacoustics is essentially using sound as a way to detect the presence of very unique signatures, right? So bioacoustics is a study that's been around, or a science that's been around for years. But the idea or the ability of using acoustics, combining it with machine learning and AI, is what we do at Rainforest Connection. So being able to use acoustics, what we do is we use these. We have a device we call it the Rainforest Connection Guardian. It's this IoT-based piece of hardware that we install really high up a tree. So we climb up 150, 200 foot up a tree in the middle of the forest.
Or people who work for you do?
I've done that several times
okay.
in several places. Yeah, for sure. Most recently, I did that in Thailand at a project. But yeah, we have several people around the world. We focus on rainforests in Brazil and Indonesia and Malaysia. And we install these devices. They're basically like acoustic sensors. They're sound recorders. And their job is to transmit the audio to the cloud, and working with Hitachi through their cloud analytics and all the great stuff that they do on the cloud side, we're able to take this data and superimpose it with machine learning and AI and make specific detections in that sound. So, for example, deforestation, one way to know that a forest is being cut down is listening to the sound of chainsaws. So we can detect very specific sound signatures, such as chainsaws, and that allows us to, in real time, notify people on the ground that there's deforestation activity that's occurring. But we also use that technology as well for species monitoring. So we're able to detect hundreds of different species that are very vital to the health of the forest.
And I will add, how Hitachi comes into the picture. Our mission at Hitachi is powering good. So, it makes perfect sense to be collaborating with the Rainforest Connection and helping provide a lot of the back-end technology that essentially allows Bourhan's team to be able to detect, whether that is a logging event that's about to occur, or, a potential species going extinct, or what have you. And fundamentally, the way the technology works at the back end is using a combination of AI and ML, where these acoustic sound patterns are being analyzed, and there is ways to detect certain patterns, certain anomalies, which in turn trigger an alert that says there's potentially a deforestation event, there's a logger that may be in the vicinity or what have you, that in turn then triggers a series of actions. So fundamentally, the way this works is, using technologies like convolutional neural networks, there's repetitive training that happens on the data sets, and that essentially allows us to be able to implement these models that very quickly flag anything that requires immediate corrective action.
Okay, so I'm a science journalist, not a tech journalist. Not to make this crude, it's probably much more complicated, but is it like when we talk into Siri, it goes into the cloud, some sort of magical AI processes it? Is this the same principle, but with chainsaws and animal noises?
Yes, indeed. So as you can imagine, these sensors that Bourhan talked about that are up on the trees, they're transmitting huge volumes of data, right? So these sensors are constantly transmitting data. And so the collection, the volume of data that is accumulated is fairly large and very dynamic in nature as well. And exactly to your point, there's multiple ways that we address it. Part of, depending upon, again, the quantity of data and the infrastructure available, sometimes this data gets relayed back into the cloud where, the processing takes place. Essentially the AI and ML kicks in at the cloud. Or there are instances as well where these need to happen at the edge, just because there may not be a mechanism to be able to transport those volumes of data, just given connectivity constraints and so forth. So both of those end up being the case depending upon the deployment model.
Yeah, so one way to think of sound, the human ear, once it hears sounds, you're kind of hearing a single dimensional, you're hearing specific frequencies or just the intensity of the sound itself. What we actually receive through our devices, think of it almost as a 3D representation of the sound itself. So a spectrogram is a representation of what that sound would look like from a standpoint of its intensity, its amplitude, its frequency, and all those kind of things. And that's where our AI and ML focuses, on essentially interpreting this 3D version of the sound, being able to interpret that. And over time, as we train a machine model, as we train a convolutional neural network, over time with multiple examples. For example, the chainsaw was trained to date with over 22,000 examples. So as we keep feeding the model more examples, it's going to get better and better at being able to detect that sound. So a chainsaw detection, for example, we can now take that same model and apply it across different soundscapes, different types of forests, and it will still perform with a high degree of accuracy.
Can we talk generally about the scale of this problem? Why would it be necessary for such a device? Why can't we just say to certain countries, figure out this deforestation problem? Are there crews that are just hiding in the forest and deforesting? In the grand scheme of fighting deforestation, why would you need devices like this?
Yeah, taking a step back and talking a little bit about why deforestation is such a huge problem. Deforestation in tropical forests account to more than 20% of the global greenhouse gas emission. If you look at road transportation, so if you combine all the trucks in the world and all the vehicles in the world, that contributes to about 15% of the global greenhouse gas emission. So deforestation accounts to more greenhouse gas emission than all of road transportation. And if you look at countries like Brazil or Indonesia, 80% of Indonesia's greenhouse gas emission is from tropical deforestation. 70% of Brazil's greenhouse gas emission is from tropical deforestation. And species conservation goes hand in hand with forest protection. So one way to protect forests is to be able to detect things like deforestation and any kind of activities that are occurring, any kind of human intervention, so to speak. But another important part is to protect the animals and the species that inhabit those forests, because they're intertwined and they, work hand in hand together, right? Some species are known to disperse seeds and very vital to the health of the forest itself. So being able to attack it from both of these angles, the first angle being stopping the illegal activity before it happens, or stopping it in real time as it's occurring, number one. And number two, being able to use acoustics and other technologies to conserve species and protect species. Putting these two together is really one of the most effective ways to protecting forests and ecosystems around the world.
I think really to emphasize the emissions side of this as well, when it comes to deforestation in tropical areas in particular, you have slash and burn, and that usually ignites peat, which is concentrated carbon in the ground that smolders for months on end.
That's right.
It sullies the outdoor air, it makes people very sick, and massive amounts of carbon emissions from
Absolutely.
that. So to put a finer point on that, this is a huge emissions problem in addition to the biodiversity crisis.
Absolutely.
And when it comes to deploying this out in these field trials, maybe you could talk about your partnership, what you're seeing to improve upon as this develops, stumbling blocks that you've come across. I imagine working out in a rainforest, there are a number of those.
Yeah, I think there's a couple of ways which we're working together on that. Number one, as Radhika pinpointed earlier, this sheer scale of data. I think to date on our bioacoustic platform, we have over 47 million samples or recording of audio from 36 countries around the world. And all that is used for not just threat detection, but also for soundscape analysis. So being able to capture all of this data and scale it in ways that we can't imagine how Hitachi is helping us very, very much so in that perspective. The other aspect of it is also in the sensors themselves. So being able to scale the tech in such a way where it becomes easy to install, it becomes cheaper to produce. We can make it readily available to organizations around the world, and hopefully extend it beyond what we're doing as an organization, and have it as an open platform that other people can contribute to it and build it. So being able to capitalize on the skills of Hitachi to be able to do that at a scale, I think is another important aspect as well.
Yeah, and just to add to what Bourhan said, I think as you start to think about this model working effectively across the globe, right? Because we're not even scratching the surface in terms of the rainforest coverage that is being implemented today. So as you think about what scale that might lead to, there's obviously going to be huge gobs of data getting relayed back. And as well, there will be multiple requirements to detect additional patterns and so forth. And so this is where we believe within Hitachi, our skill set as it pertains to data and data insights becomes critical, because not only are you talking about needing to run effective AI ML models, you also need to make sure that the data coming in is curated, is cleansed, and there is a set of processing that needs to happen on the data itself before you're able to start applying algorithms and training and so forth. And so, as the scale of this grows, we definitely see the potential for, more involvement and a closer collaboration. As well, Bourhan and I have talked about adjacencies that you can expand this to, right? We talked about species extinction and so on. There are applications in marine biology and so forth. So as you start to take this to the next level, there's multiple opportunities to enhance the quality of the data underneath, and then ensure that the right training models are built on top of it.
Yeah, and speaking of the data, I think it's really fascinating to watch this nascent field develop. I mean, this is data that existed out in nature. There were always these sounds, but scientists have really just started to build these data sets. And I was curious if you could talk about what that might inform as far as both the science and the conservation is going forward, why you need these long-term data sets to see how these ecosystems might be transforming over time.
Yeah, I think the importance of long-term monitoring, and specifically the beauty of acoustic monitoring is that it's able to detect at a field of range that is much bigger than pretty much anything else. Like if you have cameras, they have a very limited field of view. With acoustics, you can detect from kilometers away, sound signatures and species and other sounds. And being able to monitor the soundscape of a forest over time gives you a lot of insight on what's happening in the forest. Is it improving? Is it degrading? what the health of the forest looks like over time. So being able to continuously capture that data, and these devices just sitting there capturing that data over time, can give us a lot of insights on how our restoration efforts are, panning out, and what's happening with the forests as climate change is happening around us. So it gives us a lot of insights on what's going on, and it's very important for us to trace what that looks like.
Yeah, and just to build on what Bourhan said, I think especially as the data sets continue to mature over time, we see a potential for us to be able to deliver more accurate outcomes and actions as well. As many of you that have worked in the data space understand very well, the accuracy of the predictions is directly correlated to the efficacy of the model, and more importantly, how much training you've done and the breadth of the data set. So as that continues to improve over time, our expectation is that the outcomes and the recommendations become much more accurate as well.
Yeah.
And this, I think, gets even cooler when we start thinking about the seas, the oceans. Sound is an important component of any ecosystem on land. Species are using it to communicate. But in the ocean, you can have whales communicating for hundreds of kilometers, and you could spy on those calls and determine the health of populations and things like that. And I was wondering if you could speak to the expansion into that realm, which comes with its own complications with hydrophones and things like that. As this field develops, will we have sensors all over the place, be they oceans or forests on land?
Yeah, I mean, we've done actually a couple of applications in oceans with our technology, using hydrophones, which are essentially waterproof microphones. We did one with the Department of Fisheries and Oceans in Vancouver Bay in Canada. We did another one in Ireland. And we developed a humpback whale model and an orca model for detection. And we actually, the interesting thing in Vancouver, these hydrophones were stationary. So they're stationary positions where these hydrophones were deployed in very strategic locations. But in Ireland, it was a hydrophone that would go around on a boat and collect data at a very specific pattern, and then that data would come back to our system, and we would analyze it with AI. So I think there's different ways by which we can apply it, especially in a marine environment. I think this idea of being able to collect the data as part of a mission would probably be the most applicable. In a forest environment, the sensors that we develop at the moment, the Guardian device, actually has a pretty wide range. It can cover almost 7 square kilometers. So if you're doing just forest protection, think of it this way, by protecting the perimeter, you're protecting everything inside. So you don't need a lot of devices to be able to protect a very large area of forest, which is what's unique about what we do.
And to clarify, when we're talking about protecting whales, if you give ships enough warning from the calls of the whales going through a bay or whatever, that allows them to slow down, gives the whales more time to dive. That's the idea here. Yeah,
the interesting thing about the work that we're doing in Ireland, there's a nonprofit organization there that develops an app that ship captains and other organizations have access to, and they'll get notifications of where pods were detected, so they divert the ships away from their locations, because that's probably the number one way of how they get killed.
And I'm sure there are many more use cases that can get developed out of that marine application as well. And so what we find is that as the type of data that's streaming in varies, we have to adjust our neural network models to align with it as well. And so, clearly acoustics is an emerging area from a standpoint of understanding how AI and ML can operate with that data. And so that's a continually evolving area that we're working on.
That's actually going to be my next question, is like, as you add more of these sensors, is it like adding more internet users to the cloud. You're just building up that capacity as this field of science develops, as there's more devices out there and the oceans are on land. You're crunching the data, you're climbing up trees, apparently.
Yeah. I honestly think the scale of this should be independent from the sensors. I think what we should do is facilitate the usage of bioacoustics. So the idea behind what we're trying to do here is make bioacoustics sensor agnostic. So you could have any sensor that you want, whether it's a rainforest connection sensor or any other passive acoustic monitoring device, which there's a ton of great ones out there. But being able to bridge that gap right now between science and research in acoustics and the actual conservation actions on the ground, I think that's the importance of using predictive analytics and a platform that we're working with Hitachi on that allows us to facilitate the process of getting some of these organizations on the ground that are not technical, they're not sophisticated, get them to be able to use AI and ML and build their own recognition models and be able to identify species and identify presence of species, abundance of species, et cetera. And that helps them take immediate conservation action. So if the goal from bioacoustics is to really fast track that process end to end, from science and research all the way to actions on the ground, and be able to do that in an automated way, that's what we hope to do. And that's sort of our mission, ultimate mission of what we're trying to do at Rainforest Connection.
And you know, that's exactly what we're striving for constantly as well, because, you know, particularly as Bourhan mentioned, you know, when you're talking about ranges that need to show up, or you know, all these use cases where corrective action needs to be taken, and there's not a lot of understanding of the AI/ML technology behind it, it's incumbent on us to make sure that the recommendations are very accurate, right? Otherwise, you know, you have the situation where, you know, there could be a false alarm or a fake alert that in turn could you know, lead to a lot of inefficiencies and lack of faith in the models itself. And therefore, one of the things that we strive for working with the Rainforest Connection is to ensure that our models and our data sets continue to evolve, and that we're able to deliver those very accurate predictive analytics, as Bourhan mentioned.
Not to be a downer, but to bring this back to climate change, because everything's a climate change story. But to close out here with the last couple of minutes, if we could talk about, kind of bring us back to, this is very much about biodiversity, about protecting these forests, but both the forests, as they capture carbon, as do the oceans process all of the carbon, the excess carbon that we put into the atmosphere as a species. What can sound actually get us when it comes to fighting climate change?
Yeah, I mean, I think being able to understand, you know, climate change is happening, and it's moving a lot faster in the recent years than we've ever imagined. Very similar to, for example, what Gavin was saying earlier in his presentation about being able to measure emission. I think being able to measure the change in the soundscape, the change in ecosystems, whether it's oceans or it's forest, as climate change is occurring, I think it's going to give scientists and researchers, you know, a bit of an upper hand on the actions that they need to take to mitigate that. So if we're able to map that out and we're able to monitor that in a real-time way and understand the changes that are happening as climate change is occurring, I think it hopefully can give us the upper hand to being able to take corrective actions.
Okay, any final thoughts with 45 seconds left?
I'll let you go first.
I mean, yeah, I encourage everyone to learn more about the work that we're doing at Rainforest Connection. One of the ways is you can download the Rainforest Connection app, which actually gives you a real-time live stream of these guardians that are installed everywhere in the world. So if you want to listen in to what's happening in Indonesia or Malaysia or Brazil or any of these places, you can actually connect to one of these devices and listen to it in real time. So it's a cool way to see how the technology works, but also, you know, get yourself more in tune with what's going on with, you know, biodiversity loss and deforestation in general. I think I think it's a good way to understand the magnitude of this problem.
And I would say, don't underestimate the ability to apply software and AI ML technologies to solve some of these problems. A lot of this comes down to understanding the end outcome you're striving for and ensuring that you're doing the data collection that allows you to get to that outcome. So again, it's been an incredible experience partnering with Rainforest Connection toward getting to this outcome, and we're looking to have that level of sustainability initiatives being driven in other areas as well. So that would be my parting thoughts.
Great. Well, it's a fantastic project. Thank you very much for taking the time.
Thanks so much.
Thank you, everybody, for being here.
Thank you.